Okay, well, we're going to be done with our WinHex, correction, disk editor for right now. So we're going to go ahead and go Alt-X, and that will exit from the program. And that'll take us back to our DOS prompt. Okay, so we took a look at the files that we had before, and we see what's on there. Now we're going to go ahead and we're going to create an additional file. And we're going to use a really old style way. We're going to basically copy some text via the console to a file. Some of you that have done some Unix stuff, that's a very common thing. It's been a long time since it's been done in the Windows community, but for the purposes of this exercise, we're going to do it. So I'm going to create a new file on the A drive. It's going to be called File1. So it's got A colon. First of all, I have to get my cursor in here. So I'm going to go ahead and do the copy con, which means copy from the console my A colon and then slash file1.txt, and then I'm going to hit enter. And now anything that I type is going to be saved to the file once I give it the Control Z. So I'm going to go ahead and type this is file 1, and then I'm going to hold the Control key down and Z, and then hit enter, and it says one file copied. So if I do a directory of A, I will now see, in addition to the command com there, I will see this file1.txt. And if I were to type that out, which is the term in DOS for printing or listing, it would show this is file 1. Now I'm going to create a directory. Okay, and so my the way that you do that in DOS is the MD command. So it's MD A colon and then slash, and I'm going to call this dir in caps, dir1. Okay, and hit enter. Okay, and so if I do a directory again, I will now see that I have two files and I have a directory. I am going to put a file in that directory, and I'm going to use the same method as I did before, copy con A colon, only this time I'm going to put dir1 slash, and we're going to call this file2.txt, and I'm going to hit enter, and I'm going to put this is file 2, and then Control Z to end the input, and then enter to save it. All right. So now if I do a directory and I use directory A and I use the /s, that will go down and iterate through the subdirectories. And so if I do that and hit enter, we'll see the root directory there with command com file 1 and directory 1, and then in directory 1 I have three entries. I have two directories, a dot and a dot dot, and a file2.txt. It says there's a total of 6 files there. Well, wait a minute, there's only three files if you count command com. Well, they count the directories, including the dot and the dot dot directories, as files, and you'll understand a little bit later why, but they do. And so we have created some files on here. So we're going to crank our disk edit back up, and disk edit A, and open it up and say, okay, yeah, I get that. And it brings us up to the root directory, and you can see there the listing of the files, including the hidden ones. But now you have, in addition to the Lab2 volume, you've got file 1, which is the text file, and then you have the directory, which you'll notice over there with the flags is flagged as a directory. So that gives us a little idea of where we're going here. Now, if we were to go ahead and move our cursor down to File 1 and hit Enter, right, we'll get a hex view of that file. Now, in this particular case, because we haven't been using the DOS machine to do very much, there is just unallocated space below that. You can see all the zeros. If we had been using the DOS machine to do a bunch of things, we would end up with some likely looking gibberish below that, and that's the RAM slack. But we'll see an example of that a little bit later on. Now, if we go back up to Alt-O and we go to our directory and we come down here to the directory 1 and hit Enter, now what we're looking at here is the directory listing for the directory dir1, and we can see the dot and the dot dot entries as well as the file2.txt. And you can see that the dot entry and the dot dot entry are both listed as directories, and they're flagged as such in the attributes on the far right side. You can see that both of them are 0-byte files, right, but they have a starting cluster, in the case of the dot file, of 395. Now, if we look down at the bottom right, we will realize that we're in cluster 395. So what this is essentially telling us is that a directory is a special purpose file. It's a file entry just like the file2.txt, but it's marked as a directory in its attributes. It points to itself, this cluster, right, 395, which is where we're actually at, and it's a 0-byte because it doesn't actually have a file associated with it. There's no data associated with this. Conversely, when we get down to the next one down, which is the file2 the double dot, same deal. It's a directory, 0 bytes, but it points to cluster 0. Well, if we remember, cluster 0 is the root directory. So what the dot and the dot dot do is that they essentially tell a directory where their root, where their parent is. In this case, the root directory of cluster 1, the parent of it, in other words, is at cluster 0. And that it knows where it is because it has the dot entry, so it can find itself at each layer. And this is a technique that DOS uses throughout its subdirectory structure. Now you also notice that in the case of file 2, it starts at cluster 396, which is the next one after this. And so we're going to go ahead and look at, and once you remember 396, we're going to go Alt Object, and we're going to go to the first FAT. And we're going to go down to the 395th and 396th offset. So we're going to go down and page down here. And as we go down here, you'll notice that at our cluster offset of 395, we have an end of file. And it tells us down here that that is directory 1. That's the directory listing for 1. And notice it's an end of file, meaning it has a beginning and an end. It doesn't go anywhere. It doesn't point to any other clusters because it doesn't actually occupy any clusters. The only thing that is in cluster 395 is the directory table, the directory, if you will, of that particular directory listing of that particular directory. And if we tab one over, right, to 396, it will show us that that is actually the contents of file2.txt. And since it's only 14 bytes, right, it doesn't need to point to any other clusters, so it begins and ends there, so it's marked with an end of file. Now, we can go back up if we wanted to and look at cluster 396, but we've already done that. So I'm going to pause at this point before we move on to the next phase. Okay, so we're done for right now with Disk Editor again, so we're going to go ahead and we're going to go Alt-X to exit out of there to start the next phase of this exercise. Okay, well, we're back at our DOS prompt, and we're going to go ahead and we're going to delete that file2.txt. And so the way to do that is to use the delete command, which is DEL A:/dir1 /file2.txt, and that's going to delete that file. And so if we do a dir/a:/s, all right, now we can see that it's gone. So the only thing that's left are the dot and the .dot files. All right, so if we start our disk edit again, and it brings us right back to the directory that we left, which is the dir1. You can look at the directory table there, and it shows that the dot and the .dot file are still there and intact. Well, surprise, surprise, the file2.txt is exactly the same. It's there. The only difference is the very first character is this weird character which we call sigma. If we look at it in hex, it is hex E5. But in the case of Disk Editor, it shows up as a sigma, so you'll very often hear it referred to as a sigma or hex E5. So we see one change with the directory entry. And again, you look at it and you say, well, cluster 396 is where it was stored. Let's see what the file allocation tells us about cluster 396. Is cluster 396 available or not? If this is a deleted file, then it should be available. So we're going to go ahead and go Alt, and we're going to go down to FAT1 and hit Enter, and we're going to go down to 396. And 396 shows a 0, which means that it's available. Now, if we actually go to that cluster, you go Alt-O and go to cluster 396 and hit Enter, right, there's file 2. It's still there. And so what we've learned is that when a file is deleted in the file allocation table system, the only thing that changes is the first character of the file name is changed, it's overwritten, and the file allocation tables are zeroed out, showing that that space is available. And so if we want to restore that file, we reverse that process. What we would do, we don't have to do anything to cluster 396 because nothing has changed in terms of the data. All right? So we can go back to the object itself, and the first thing that we're going to do is we're going to say, all right, it's no longer merely available. It's actually occupied. And so in order to write that, we have to go over to our tools and go to configuration, which you can do the up arrow to shortcut having to go down through all that. Go to our configuration, and where it says read only, we go ahead and hit the space bar, which clears that. So now we have the ability to actually write here in the hex editor, which makes it very, very dangerous. And we just start using the tab until we get down to the save. And we'll go ahead and do save and hit OK. Now we're going to go Alt Object, and we're going to go to FAT1. And we're going to go down to 396. Tab over. And because we want that to be occupied, and we know it's only a 14-byte file, so the file is going to begin and end in that particular cluster. So we go ahead and we type in E, which will give us the end of file. All right. And we now need to make sure that the second FAT does the same thing. But diskEdit is pretty smart. So if we go Alt-O and we say, all right, we want to go to the second FAT, all right, it will say, wait a minute, changes have been made to that sector. Do you want to update both copies? And the answer, of course, should be yes. All right, and so you just have to highlight it until you have the W, or you can just press W to do it and hit enter. It says changes have been made. Do you want to rescan the disk to make to reflect the changes that were made? And you should do that. And so we're going to go ahead and hit the R for rescan. It says, wait a minute, there's an error there. Well, the error is that we have not changed the directory entry. So now you have a deleted directory entry and a cluster that is allocated, and that's what the issue is. And if we type V, it'll say there are lost clusters found on drive A. Lost clusters are clusters that are allocated, but they're not attached to any of the directory entries. And that's true because we haven't finished doing this. So we'll hit C, hit escape for that. And we'll go Alt Object, and we're going to go to the directory now. All right, we're going to go to directory 1, and you look down here to the directory entry. And by the way, if we do F2, all right, we can see, all right, the sigma on the right-hand side, all right, here that we see in kind of English, if you will, is actually a hex E5 when you look at it in hex. So we're going to go back to our directory view of it, Alt Object and directory, and we're going to come down here, and we're going to change our sigma to a printable character, which will recover the file. Now, we don't know in theory as a forensic examiner what that character was, because once it's overwritten, it's overwritten. Now, we happen to know that it was an F because we were the ones that did it. But if we were bad guys, we wouldn't know what it used to be. And if we're examiners trying to figure out what the bad guy did, we wouldn't know what the bad guy had done. So we're going to go ahead and use the exclamation point as a placeholder. And we're going to go ahead and delete that, that sigma. So we have changed the first letter from sigma to this exclamation point. We're using the exclamation point as a placeholder because we don't know what the original one was. Now we can go ahead and we can go ahead and see if we've created any problems. So we're going to go Alt Object again, and we're going to read the directory again. It says changes have been made to cluster 395, and that's where directory 1 is, and we're going to say yes, we know that. We want to hit a W to write it, and then we're going to go reread it, and it comes back and it doesn't have any errors. It has now found it. And in fact, if we go Alt X to get out of this and we do a directory, now we'll see that we have that file of the exclamation point ile2.txt. You now have all the skills that you need in order to recover deleted files from DOS or FAT file systems. The only tricky part that you're going to have is when you have files that are longer than a single cluster. You're going to have to what you call chain them together, and you're going to have to determine if they are in sequence. And we will give you an exercise to do that, and that's what your lab is going to be about. But I encourage you to go through and redo what I've done here in the video, utilizing the Lab 2 worksheet that you will be able to download from the Learning Management System. That's all there is for this particular video. Until next time, have a good day.